21st century, by many scientists, is termed as the century of biology, and with the recent developments in genome editing technologies, this looks very likely to be the case. In the next decade and beyond, biochemical engineers will have a significant contribution to human health and well-being by improvements in the development of new cell-based therapies, new medicines, as well as environmentally friendly bioprocesses and biomaterials from renewable sources.
When I visited the department on an open day a year ago, I was introduced to the pilot plant. And I came to know that UCL has probably one of the largest, if not the largest, academic bioprocessing centre in the entire UK. So that was one thing which certainly attracted me. Most other universities which do offer the biochemical engineering degree, it's usually a specialisation of the chemical engineering degree. So it's usually offered by a chemical engineering department. However, at UCL, there is a specialised department for biochemical engineering.
When we moved here, I was freshly graduated from my master's in Budapest, and I was trying to look for a job. I didn't have any references, so that was one of the other reasons I came to study at UCL. And here I managed to build lots of connections within the department and through the department with companies. Institute for Chemical Engineering. It's very, very useful. Like getting notifications of all the jobs that are open was very helpful in terms of getting my CV ready and personal statements. Everyone signs up at the end of their masters. Very easy to take part. There are lots of events going on.
The MSc program is tailored to reflect recent development and innovations in the field. So we got delegates from the industry coming to the program with us. We're able to speak to them, and then with the case studies we had, we actually went through the industrial case scenarios where we can really apply what we've learned. So it opened our eyes to so many things like, okay, this thing we learned is actually very applicable to the industry.
Obviously, we have the three streams, but that doesn't mean that it's three isolated streams. For many of the modules, all three streams are in the same classroom. They work together, they work on group projects, and they interact. It's very interesting to see the dynamic of how a life scientist slowly converts into an engineer, and an engineer starts taking more into consideration biological aspects and the complexity introduced from biology. The engineering stream of our MSc trains students on the use of engineering calculations to study the flow of mass, heat and fluids in bioprocesses, to design bioprocess equipment such as bioreactors and centrifuges, to design entire bioprocesses and to evaluate their economic performance and profitability. Our second stream is the science stream, and that is for students that have an undergraduate degree in another engineering discipline and want to be retrained as biochemical engineers. So they have the underlying concepts of design and process design, and they want to learn the complexities that are introduced from the biological component. The biochemical engineering stream, that is for graduates with a biochemical engineering background or a general bioprocessing background who wish to perform advanced studies in the field. These students will be trained in cutting-edge technologies in the field, including vaccine bioprocessing, microfluidics, synthetic biology, and really the latest developments in the field.
It is something which would really stand out in my applications as well. The fact that there are MBI modules which are incorporated into my course, that is really ideal for someone who is looking to enter the bioprocessing industry.
The modules, in my opinion, were a very good selection. I really gained a lot during the masters.